Welcome to this explainer. Today, we're diving into something that is honestly going to completely change how you view your own decisions, the technology around us, and, well, your own mind. So get comfortable, take a breath, and let's jump right into it.
Think about it for a second. We live in a world that is just overflowing with answers. I mean, search engines literally deliver results instantly. AI is predicting the very next words we're going to type. Dashboards are refreshing every single second. And yet, ask yourself, why do we all still feel so uncertain? Why do incredibly smart people make such remarkably poor decisions? Why do whole organizations just collapse? And why do seemingly simple problems suddenly turn into massive, complex headaches? We usually think, hey, if I just had a little more data, a little more clarity, the confusion would totally vanish. But what if that assumption is completely backwards?
You see, we fall into this trap of believing that more information is always better. But let's challenge that for a minute. Think of information kind of like water pouring into a glass. If that glass doesn't have a solid shape, the water just spills everywhere and makes a total mess. Confusion almost never comes from a lack of information. It usually comes from unstructured information. Information is easy, right? It moves. It can be borrowed, copied, pasted. But understanding stays with you. It provides the actual structure. You can't just borrow it. You really have to earn it. When people get confused, their first instinct is to just go grab more information. But without a framework, you're literally just adding weight to your own confusion.
And that brings us to the absolute core of today's explainer. We're exploring the brilliant insights from Ravindra Nayak's book trilogy, Thinking Systems for an Uncertain World, a first, second, and third principles journey into modern intelligence. By the way, I highly encourage you to support the author and pick up a copy for yourself using the link down in the description. Now, what makes this book so profoundly different is that it doesn't just hand you some shiny new tech tool or a quick top 10 list of answers. Instead, it completely strips away our false certainty. It reminds us of this beautiful idea: a note is not a verdict, a gap is not a scar, meaning the work can be repaired from exactly where we are right now. It's an invitation to stop judging ourselves and actually start seeing things clearly.
So you're probably wondering, okay, how do we actually begin to earn that understanding? Well, let's dive into it. It all starts with first principles thinking. This basically means breaking a problem down to its absolute fundamental truths, the things that remain true even if all the fancy jargon, the latest trends, and the software tools completely disappear. We really have to strip away the noise and the borrowed assumptions. Imagine a beginner trying to learn AI by memorizing 10 different software frameworks. They're going to drown in mental noise, right? First principles thinking demands that we stop staring at the tools and start looking at the underlying reality.
To get there, we got to do something that feels pretty unnatural these days. We have to adopt the first principles pause. When we face a complex issue, our modern reflex is to immediately grab a tool or rush to formulate a solution. But this trilogy teaches us a totally different rhythm. 1. Pause before you act. 2. Question before you try to solve it. And 3. Actually understand it before you start optimizing. Before you ask what software can solve a problem, you have to ask what reality is trying to teach you. Motion feels safer than silence, so we rush. But true understanding? That requires standing still long enough for the truth to become obvious.
If we skip that pause, man, even the absolute smartest people fall into these predictable traps. Look at these common system failure modes. The first one is honestly haunting: answering the wrong question clearly. I mean, it doesn't matter how brilliant your data model is if it's optimizing for the wrong goal. Highly intelligent people fail when they only ask, can this work? A first principles thinker looks at the whole system and asks, okay, how can this fail and how will we know? By hiding uncertainty or automating a process that is already broken at its core, we aren't solving problems, we're literally just scaling our mistakes.
All right, let's shift gears into part 1, thinking in systems, second principles in motion. Because here's the thing, in the real world, absolutely nothing exists in a vacuum. Every single action you take influences something else, creating these invisible feedback loops. And this brilliantly illustrates why isolated improvements can actually be super destructive. When you optimize just one piece of a system, say making one single department in a company hyper-efficient, you don't actually eliminate the pressure, you just shift it somewhere else. That newly optimized department works so fast that it completely overwhelms the next department down the line. Optimization shifts pressure, and it reveals hidden constraints that you never even bother to measure. So improving one part without understanding the whole thing, it often destabilizes the entire operation. Picture this. You've got a bustling city, and they decide to perfectly synchronize all the traffic lights in just one single wealthy neighborhood. Traffic flows beautifully there, right? Faster than ever before. But where do all those cars go? They slam right into the borders of the adjacent neighborhoods, creating gridlock so severe that the entire city's transit network comes to a grinding halt. The collapse wasn't caused by a failure or an error, it was caused by an unbalanced success. As the book points out, systems don't break when something fails, they break when something succeeds way too fast.
Let's see how this builds into the technology we rely on every single day. Because the real world is messy, delayed, and super resistant to our control, uncertainty is quite literally everywhere. Artificial intelligence and machine learning, they don't operate on perfect, flawless logic, they operate on probability. Probability is the mathematical language machines use to navigate an unpredictable world. It's how they measure the honest gap between the evidence they currently have and the future reality they are trying to predict.
Now, wait a minute. Doesn't being uncertain mean the system is, I don't know, weak or failing? Actually, scratch that. The exact opposite is true. We have to separate honest uncertainty from false certainty. An AI that gives you a perfectly confident single answer when the data is super messy isn't intelligent, it's reckless. False certainty is incredibly dangerous because it hides gaps in knowledge and masks massive risks. But honest uncertainty, like a system saying, hey, I'm 70% confident, but here are the edge cases, that is a feature of real intelligence. It enables adaptation. It signals that the system actually gets the limits of its own knowledge.
I really want you to let this sink in for a moment. Intelligence is not how much information a system has, but how carefully information is allowed to move. It is not about possessing a massive database. It's about boundaries. It is about knowing exactly when to stop, when to ask a clarifying question, and when to outright refuse to make a prediction because the stakes are simply too high. Careful flow, not rapid output, is the true hallmark of a thinking system.
Which brings us to part 2, designing under uncertainty, the human responsibility.
Imagine you're standing at a crossroads. Down one path is perfect, fake certainty. Down the other is deep, honest awareness. As we navigate that choice, it's fascinating to see how our partnership with technology contrasts. Machine intelligence was literally engineered to operate in structured information spaces. It is brilliant at consistency, processing sequences, and recognizing patterns at a scale we can't even fathom. But human intelligence? We evolved to survive in an unpredictable, messy physical world. Our role isn't to compete with the machine's processing speed. Our role is to provide the ethical judgment, the lived context, and the accountability that the machine fundamentally lacks.
So you might be thinking, okay, if the machines can do all the heavy lifting and processing, what's actually left for us? The answer is wisdom, the wisdom of constraint. While an AI will enthusiastically ask, can we do this? Human wisdom has to step in and ask, what matters most here? What kind of future are we actually building? What human good is being served or harmed? And critically, what must remain deeply human? AI gives us astonishing, mind-blowing capabilities, but we humans must be the stewards of those capabilities. We absolutely cannot forget this. Optimization does not equal meaning. A machine learning model can optimize an objective flawlessly, millions of times over, without ever having a clue why it's doing it. It doesn't know who is affected by its decisions. It simply adjusts numbers to improve a metric. The correlation survives, sure, but meaning? Meaning never appears in the math. Meaning is a property of human participation. It only exists right where interpretation and consequence intersect. So the big takeaway here is that models are not reality. They're just maps. And a map stops helping you the exact moment the actual terrain changes. If we start confusing the data with the real world, we start making decisions that look absolutely fantastic on a dashboard, but end up causing immense harm to actual people. We have to treat models as components of a system, not as unquestionable oracles of truth.
And this brings us to a massive realization. True intelligence isn't just about blind capability. Just because a system is smart enough to generate a highly convincing answer doesn't mean it's responsible enough to own the outcome. Responsibility, that doesn't live inside the algorithm. It lives with us. Limits are not what intelligence fights against. Limits are what intelligence works within. Knowing when to escalate a problem to a human, knowing when to pause, and knowing when to just say, I don't know, that is the ultimate sign of a mature, intelligent system.
As we wrap up this explainer today, I want to leave you with a fundamental shift in perspective. You are no longer just a consumer of information. You are a steward of it. Artificial intelligence can assist with speed, synthesis, and pattern recognition. It can mimic certainty incredibly well, but it cannot relieve us of our humanity. AI can assist intelligence, but what will you do with your wisdom? Thank you so much for joining me on this journey.